Hello class, today we're going to be continuing with systems of equations, but now we're going to try to look at some real world scenarios, which just means we're going to be looking at word problems. And the main difference between our word problems and any other problem that we're given is we're going to have to either figure out the equation and interpret the context, or we're just going to have to interpret a context. A lot of the time, you will be given problems where they give us the equations for our systems of equations already, but we're not going to look at those today because we're effectively going to take the step to find those two anyways. Okay, so let's look at our first problem here. Tyler prepares overnight oats for his breakfast each morning during the work week. He adds chia seeds for additional nutrition. He buys the chia seeds and the steel-cut oats he uses at a local bulk store. Last month, he purchased 0.8 pounds of chia seeds and 2.5 pounds of steel-cut oats for $8.82. This month, he bought 0.4 pounds of chia seeds and 3 pounds of steel-cut oats for $7.79. Okay. Now they want to write a system of equations that we can use to find the price per pound for chia seeds and steel-cut oats at the bulk store. And then we define the variables used. Alright, so let's look at try to figure out what all of the important information is first. So we know he's buying chia seeds and oats. Both of those are coming from the same place. Okay, so we have one purchase up here. We'll use green to represent our first purchase. So our first purchase last month, 0.8 pounds of chia seeds and 2.5 pounds of steel-cut oats for a total cost. Okay, so I'm going to write our chia seeds as C and our steel-cut oats as O. We'll just label that as chia and as our oats. Okay. Let me just put some colons there. Make it look a little nicer. Now, in that first purchase, we had 0.8 pounds of chia seeds. So I have 0.8 pounds of chia plus we have 2.5 pounds of steel-cut oats. So I have 2.5 pounds of our oats. I'm going to put a little dot in the O to make sure it doesn't look like a zero. And this was equal to our price of 8.82. As we have $8.82. Okay. Now let's look at the next sentence because he bought oats and the chia seeds twice. So in the second month, this is the separate time he goes to the store. He bought 0.4 pounds of chia seeds and 3 pounds of oats for $7.79. Okay, so let's look at our first part here. We have 0.4 pounds of chia seeds. So we have 0.4 pounds of our chia seeds. Plus he also bought, remember and means plus, 3 pounds of our steel-cut oats. I'll put a little dot in there just to show that's oats. Maybe it could have gone with a T, but that's fine. And that is equal to our 7.79. Okay. So now that we have our two equations here, what we can use is either our substitution or elimination to be able to figure out what the pounds of chia in the pounds of oats are. So what I want you to do is I want you to take a second, use any method that you like, either substitution or elimination, to figure out what C is, and I guess I could use a different color for both of these. I want you to figure out what C is equal to and what, okay. So let's look at the next one. Now, we're looking at the average homeowner in Florida is paying $150 a month on their energy bills. Okay, it's probably important because they're giving us information here. Some owners choose to install solar panels to reduce their monthly energy cost to an average of $55 per month. Okay, so if they have solar panels, we have an average of $55 per month. The cost of purchasing and installing solar panels is $13,000 on average. Okay, so that's the information they're giving us. Now what they're asking us to do is write a system of equations that can be used to determine how many months it will take for the total cost of energy bills without solar panels to cost the same as energy bills with solar panels. Okay, so we want the total bills to be the same. So let's let B represent our bills and let M represent the number of months. Okay, now we need to write two equations because we have two variables here, right? So let's look at the first situation. If somebody in Florida does not have solar, they're paying $150 per month. Per is multiply, so 150 times M, and that's equal to their bill. Okay. Now let's look at our second situation. If we have our homeowners are choosing to install solar panels, when we're installing solar panels, it's expensive. It's $13,250. Plus, they still have to pay some of the energy bill every month, which on average is $55. So plus $55 per month is equal to how much they're paying in the bills. Okay. Now, a lot of time with solar panels nowadays, you can pretty much get your whole bill covered. And if you're making extra energy, which is pretty common, especially in Florida during the summer months, the energy companies will actually pay you a little bit back because they'll take the energy you're not using. But, so we have two equations and we have two variables. So now we can use either substitution or elimination to solve these. Take a couple minutes, give these a go. Use any method you like. Okay. So now, personally, I decided to use substitution to solve these. The reason I chose substitution is we have equations that are equal to a variable. So a lot of the times that can make it a little bit easier to use substitution. If you did use elimination, that's okay. That's fine. But we should have gotten something where we're about 139.474 months. Which would be about 140 months. It told us to round to the nearest thousandth, so we're going to leave it as the nearest thousandth. And for our bill, it'd be about $20,921 with 0.053 cents. Now, if you're thinking about whether or not you want to buy solar panels, obviously it does take like 139 months, it's like 10 years to pay it off. If you're paying just the same amount as your energy bill, what you would have been paying anyways. But you gotta remember, energy prices will continue to go up with inflation too. So it's a bit of a trade-off. Now, last thing we need to do is interpret the solutions, which we kind of just did. But our M, that's representing the number of months. So if I wanted to interpret the solution, it's 130, point there when I shouldn't have. We have 139.474 months. I guess I could just type this. Months. We have about 140 months-ish until the price of purchasing solar panels is the same as the energy bill of not purchasing solar panels. Purchasing solar panels is gonna be wrong. Yeah. Wow. Doing this middle of the day, and I think the computer might be the slowest I've seen it here. Yeah. Okay. The price of solar panels, purchasing solar panels equals the price of not purchasing solar panels. Okay, so who is jumping? Okay, let's extend the page so I have one more space. Yep. Yep, and then the price that it would be, the bill after those like 10 years, is it's going to be the 20,000 here. So the price when this happens is our B, which is our 20,921.053 dollars. So pretty much what this is saying is, if you buy solar panels, it's going to take about 140 months to pay it off, and then at that point your energy bill would have been the same price anyways. And after that 10 years, the energy bill, or buying the solar panels and the energy bill, would be about $20K. After that, you just have a discount for the solar panels. Okay, so we'll do one more example. For this one, I want you guys to take a second to write out what you think the two different equations are, and then solve that system of equation with any method that you like. You can ignore the 9 and 10 year, just act like it's an A and B. Okay, and go. Okay, so you should have gotten that we have some variable for lifeguard hours, some variable for cashier. I chose L and C, L for lifeguard, C for cashier. The equations they set up is that we have twice as many hours as a lifeguard as a cashier, so 2C is equal to L. And we have that he was making $12 an hour with C, so per hour, so we have 12 times C, plus $18 per hour as a lifeguard, so 18 times L was equal to the total amount he made, 144. I chose to use substitution here because we have an equation that's already equal to a variable. 2C is equal to L, so I plugged 2C in for L, and then we can solve for C. Gives us 3. Plugging 3 back into either equation, doesn't matter which one. I chose to go with 2C equals L because it's easier to plug into, so we get 6 is equal to L. So we have 3 hours worked as a cashier, 6 hours worked as a lifeguard. Hope you guys have a great rest of your day.